Sci9, Mr. Beeland here with your lesson for today. We are talking about resistance. And in particular, in the context of our unit, we're talking about resistance with electricity, right? So what is resistance? Resistance is a property of a material to slow down the flow of electrons. Okay, so once again, resistance is the property of a material to slow down the flow of electrons. You remember the flow of electrons, that was our electrical current, right? So a good conductor, right? We remember conductors and insulators. Conductors have low resistance, and insulators have high resistance. Again, this is how easily electrons can move through a material. So something like copper would be a good conductor because it has low resistance. And something like our skin is not nearly as good of a conductor, it's a bit more of an insulator because it does have higher resistance, right? This is why when we are trying to touch the doorknobs, which are made out of metal, and they have a very low resistance, that is why the electrons, if we did build up any static, let's say the wool or something, if we run our feet across the ground, that will easily jump across to the low resistance conductor. Now, when we're talking about our batteries and hooking them up to electrical components, sometimes our batteries are too strong for what we're trying to hook up to our battery, right? And if we just let the battery and the full potential difference and the movement of electrons go through a component, you could overload said component and cause it to burn out or something. So we have this special thing called, it's gonna be a big surprise, it's called a resistor. Okay, and so unlike other different types of electrical components like a light bulb or a speaker or something that you're going to have electrons flow through and then it's going to do something like light up, a resistor's whole job is to slow down that flow of electrons, right? Just to slow it down a little bit so that not as much is going through so that you don't overload and burn out whatever your circuit has going on, okay? So again, we're gonna imagine this with our rock, right? And we're putting our rock at the top of a hill. And then when the rock is up here, this is the potential difference, right? This is the voltage, right? It's your battery, you're holding on to it, but it's not doing anything because it's not rolling down the hill yet. So that is your potential difference. As we push this off, we plug in that battery, and this rock starts going down this way, this is basically our current, right? There's an active flow, right? The rock is rolling down the hill. So then what would the resistor be? Well, the resistor would be something like maybe a bump over here or a slight ledge or something like that. That is the resistance or the resistor, right? It doesn't do anything else except for slow down that rock so that it doesn't go down and smash whatever's down there. Yes, so these three things, voltage, current, resistance, are all very closely connected together in something that we call Ohm's law. And Ohm's law states that resistance of your object or your material is equal to the potential difference divided by the flow of electrons, or the current. Okay, so what does this mean? We can have a formula. This formula could be written as R equals V divided by I, where R is resistance, V is voltage, I is current. Now remember, voltage measured in volts. Current is measured in amps. We've already talked about those two. Resistance, what is resistance measured in? It is measured in ohms, okay? This is the unit here. And with these two again, voltage V for volts, current had A for amps, right? Resistance, ohms, what's the symbol for ohms? It actually looks like this. Almost like an upside down horseshoe, okay? This is the omega symbol in Greek. That is the symbol we use for that. Okay, so we've got this formula here, and what can we do with this? Well, we can talk about some word problem type situations, right? For example, I could say that I have a light bulb, and this light bulb has a potential difference of 6 volts. Okay, so potential diff across this light bulb of 6 volts. And it has 1.5 amps running through it. We can find the resistance of this light bulb, right? So find R. So again, this is just a word problem. All we have to do is take this information and plug it into our formula and then solve it, right? So our potential difference, our voltage is 6 volts. So V is equal to 6. And we have 1.5 amps. Amps is current. And then we just take 6 divided by 1.5. So we would have 4 ohms of resistance in this light bulb. Now we have this formula. It may not always be the case that we're looking for R, right? We could be given R and I and asked to find V. So you do need to be able to rearrange this formula, multiplying the I up to the top or swapping these around. In order to find the I, you will have to be able to rearrange this formula. A good trick is to use something called the triangle of science. And this is good for lots of formulas, okay? So what we're going to do is I'm going to draw this triangle. And I'm going to break it up like this. And this triangle gets broken up into 3 parts, so we've got 3 variables. V, I, and R. So now, whenever you have a problem and you're asked to find something, what you're going to do is you're going to, in that case, remember we were trying to find R. We're going to cover R up. And then we're going to look at the formula and see what's left. V over I. Done. That's the formula we're going to have to use. We would just plug in V divided by I. If I was missing, V divided by R. Same thing. And then finally, if we were trying to find voltage, they're beside each other, so we're going to multiply I times R. Okay, so this is a nice little trick. Again, you don't necessarily have to use it. You could just plug everything in and then rearrange it to find your unknown. But this is a handy little trick. So again, let's just go through one more example here to make sure that we understand. So let's say I have something that has, let's say I've got a speaker, and I know that the speaker has 10 ohms of resistance. And I want to put maybe half an amp, 0.5 amps through this speaker. How much or how strong of a battery would I need to do that? So I would go and look at my thing. I want to find V, right? Because I got to figure out my battery strengths. I would cover my V, and I would see that it's I times R. So V equals IR, which equals 10 times 0.5, which equals 5 volts, which would mean you basically would need around 3 AA batteries, which would give you about 4.5 volts. Anyways, the main part of this, the main takeaway for this is this formula, Ohm's law, okay? So there are going to be some practice questions for today. There's going to be some practice questions for next class to make sure that we get down Ohm's law. We have to understand Ohm's law before we can talk about applying it to some more complicated cases of circuits, okay? So if you have any questions, please let me know. Okay, there will be a small quiz on Ohm's law in 2 classes from now, okay? So today's Wednesday. Friday, you have your second half of this to practice. Then the following lesson or the following day will be the quiz, okay? Again, it's 5 questions. Very small, just to make sure that you have an understanding of Ohm's law. Okay, very long. Thanks for sticking it out. Take care.